Okay, now we are doing surface areas and volumes of spheres. Okay, so a surface area of a sphere, so you have a ball, imagine a ball or a baseball. If you look at a baseball and it's kind of cut out like this, I mean, if you cut it all out and flattened it out, it'd kind of look like that, wouldn't it? It'd flatten all out and then it peels all back together. So they do kind of look like about 4 circles, doesn't it? Like if you had a baseball and you did that, sorry, that's really not a very good picture, but if you did that, you could see it'd be about 4 circles. So what the surface area, if we took this and flattened it all out, the surface area would be the area of a circle and then 4 times that. So that is the surface area of a sphere. So if you know the radius of your sphere is 5, then it would be 4 pi 5 squared, and that would be equal to, that's 5 times 5, 25 times 4, that would be equal to 100 pi, 100 pi, and if that's inches, it would be inches squared. And that would be the surface area of a sphere. Now, if you want to do the volume of a sphere, the volume is what will fill the inside, and that formula for a volume is equal to 4/3 pi r cubed. Okay, because remember, a volume is r cubed. So this is kind of, this is one you just kind of have to memorize. It's 4/3 pi r cubed is the volume. And if you have, say this is, the radius is 13 inches, then it would be, the volume of this sphere up here would be 4/3 pi, and it would be 13 cubed, or 13 times 13 times 13, and that number ends up being 9,202.77 feet cubed. If this was, well, inches cubed, if it was inches. Inches cubed up here, inches. Okay, if you wanted to do a, say your radius, I'll do one more with you. Say this radius was 6 centimeters, and the volume of the sphere with 6 centimeters here would be 4/3 pi, and that would be 6 cubed. 4/3 pi 6 cubed. And that would equal a volume of 904.78 centimeters, if it's centimeters cubed. And if they said we want the hemisphere, then what you do, if they want a hemisphere, is you just divide this by 2. So you figure the whole sphere, and then you cut it in half if they're asking for the volume of a hemisphere. If they're asking for a volume, a surface area, to find the surface area of a hemisphere, they do the same thing. So this surface area here of this one would be 6 squared, so it would be 36 times 4, whatever that is, 36 or 24, 144 centimeters squared for the surface area of this particular sphere, and then you would have to divide by 2 to get the hemisphere, whatever that would end up being to get the hemisphere here. Okay. And that covers the spheres there. We do the surface area and the volumes for that.